Hey there, creative coders. This is Benjamin D. Whiting, and welcome back to the Super Collider segment of Null-state's interactive digital art tutorial series. Last week, okay, you got me. We have an elephant in the room, and I feel I owe it to all of you to explain why this series went on a sudden, unexpected, and lengthy hiatus. Last year, I joined the faculty of a preeminent research university in the United States as a visiting instructor of composition and electronic music. While I was expecting my full-time professorial duties to slow me down somewhat posting videos online, I just so happened to come aboard during a year in which the New Music Consortium at the school organizes their biannual International Festival of New Music, and my duties as one of their faculty advisors had me take a leading role in putting the festival together. If you've never been a part of a venture like that before, suffice to say it takes over one's life in ways one likely wouldn't expect. Of course, I was hardly alone. My wonderful students and colleagues all pitched in and did their part, but at the end of the day I had absolutely no energy to devote to the series. Then COVID-19 happened, and the workload of academics all around the globe increased overnight as we struggled to adapt our in-person classes to an online format. Fast forward to this year, and while I'm thankfully still at that School of Music, there isn't an international festival to prepare for, so I can finally resume this tutorial series that had stalled so abruptly. On the plus side, I have learned a lot pedagogically having taught a 2-semester course on Super Collider in a real-time performance context, a course that I am repeating this year. Bringing my new perspective and teaching methodology to the table, it is my goal that this series finishes much stronger than it began. The project we will be working on remains the same, but I may take a bit more time touching upon some concepts that I might have rushed through back in mid-2019. After all, the point of the series is to not only help you familiarize yourself with this fantastic programming language and ways you can leverage it into interdisciplinary and collaborative art projects, but to instill within you the confidence needed to work efficiently and productively. Okay, on with the show. Before moving on with the next sound design segment, I thought I would take the opportunity to revisit a couple of concepts that I went over earlier in the series. After reviewing them several times upon assigning them to my students, I have determined that, while much of the content in my earlier videos was more or less sound, no pun intended, there were 2 points where I would consistently have to clarify in my own classes. To the point that I felt I should do the same here were I ever to get back to this tutorial series, these dealing with arrays and node proxies. I feel it's important to tackle these before moving on with our project, so without further ado, let's get started! Having rewatched the series several times, one thing that has bothered me was how I dealt with explaining the .new class method of array in episode 6. If you recall, Array.new is one way to declare an arrayed collection of data, and the sole argument it accepts is one called max size, which I took to mean the max indexable size of the array, since it defaults to 0. Except it turns out that isn't how it behaves. Reviewing that moment, the basic way of initializing an array is by using the .new class method, declaring its maximum index number, and setting it to a variable. This sets up an empty array, as you can see in the post window, and the array is large enough to fit up to 3 indices. Remember, arrays are 0 indexed, so index number 2 is actually the 3rd slot. Let's now set up the array we had earlier. This is most easily accomplished by using the .add instance method of array, the sole argument of which is whatever you wish to place in the next available slot. Now, let's say we suddenly realized we miscounted and wanted 4 indices in this array after all. Could we simply add it to the array and hope for the best? It worked! Let's keep going though, something doesn't quite feel right. Aha! Instead of appending the integer 8 to the array, it simply overwrote the 1. Or did it? Let's check to see what is actually registered in the 5th slot, or index 4. And there we have it, nil. Despite what we saw in the post window, there is technically nothing in index 4 of our array. What's actually going on here? While Super Collider could have simply thrown an error, halting whatever process is being executed at the moment, it instead generated a new array with the requested data added to it. This design choice was likely due to the language often being used in real-time musical performances. There's no reason to bring everything crashing to a halt for accidentally underestimating the size of an array upon declaration. The fact that some leeway is built in for eclipsing the declared maximum size supports this notion. As you saw, I took it as a sign that the developers were being kind to users, allowing for a few extra indices to be added above what was initially declared. I should really have taken more time to think about this, as I subsequently found that declaring an array using new clear affords no such luxury. In fact, I am pretty certain this is just an unintended feature. So let's begin by consulting the documentation and getting straight from the horse's mouth what Array.new is designed to do. As it says here, the .new class method of array creates a new array with size 0 that can grow up to the fixed size. So first, and what should have occurred to me when filming episode 6, is that the size argument of arrays in other languages sets the number of indices one wishes an array to hold. What I mean by that is, an array of size 5 should be able to hold 5 objects within itself, using index numbers 0 through 4. However, this couldn't possibly be the case in SuperCollider, as the default max size of an array is 0. This is why I initially presumed, and I may still be right about this, that the argument refers to the highest index number the array should hold, not the number of indices themselves. Otherwise, an array of size 0 should not be able to store anything within itself. Let's run a few tests to see for ourselves. Okay, so I'm going to begin by initializing an array. I'm going to set it to interpreter variable A, and I'm not going to include any arguments. As you recall, the default max size argument is 0, which means one of two things. It either means that the max index number is 0, and thus it can hold one item, or it means that it's fixed at a size of 0 and that it should not be able to hold anything. Somehow I don't think that's going to be the case, but let's find out. So we're going to add the integer 1 to the array. I figure it's going to be easier if we add integers in consecutive order as we do our tests. All right, so we return an array with exactly one index, and that index holds integer 1. Now we can check the value of A, and sure enough, it has the integer of 1. So far, so good. Now let's try adding the integer 2 to the array. Well, as you can see here, it's in the array, but let's not celebrate yet. This doesn't mean that it actually was added to A. This is just a new array that was returned that has both the array, the contents of array A, which is 1, with the integer 2 that we just tried to add. But if we check A, we only have 1. So I suppose this works as intended so far, but again, not so fast. Let's try this again, but now let's declare an array with a max size of 1. And let's see what happens. So we're going to go back through these steps again. So we're going to add 1 to the array. Okay. Now we're going to add 2. All right, let's check A. So, aha, so they both are in here. Interesting. Well, but if this is indeed the max index number, then that's consistent because the max index number would be 1, which would be the second entry in the array. So let's try adding 3 and see what happens. So 1, 2, 3. Huh. Well, now this isn't expected because we declared an array with a max size of 1, and yet it clearly was able to store 3 integers inside this array. Will it store a 4th? Yes, it will. Okay, let's try storing a 5th. Okay, so as you can see, we can only store up to 4 integers in this array. The max size is 1, keep in mind. So now let's start over. Let's declare an array with a max size of 2. Now, I'm not going to go through adding these integers one at a time, I think it's pretty safe to presume that whenever we increment the max size, we should be able to hold the integers that we added previously. So we're going to add 1, 2, 3, and 4 at once. And yep, it worked. Now let's go ahead and add 5. So will we be able to store this 5? Or are we still capped at 4? We're still capped at 4. Even more interesting, we incremented the max size, and yet the size of the array is still fixed to 4. It's more than 2, but it's inconsistent with the behavior up until this point, because if you remember, when the max size was 0, the array could hold 1 object. The max size is 1, it could hold 4 objects. The max size is 2, it can still only hold 4 objects. All right, let's now increase the max size to 3. Okay, as I said before, it's very likely that when we increment the max size, that the array should be able to accommodate at least as many indices as it had before. So we can just add all 4 integers in one fell swoop, add a 5, and we're still capped at 4. Are we always capped at 4? Well, so far we are. So from when we had the max index as 0, we could only add 1. 1 through 4, we can add 4 objects. What happens now if we increment it to 5? Okay, now we can hold 5 objects. So is the bug only relevant for max sizes 0 through 4? Let's find out. No, now we can add more than 5. We've added up to 6, and I suspect we will be able to add up to at least 8. Yes, we could add up to 8. I'm not going to make you sit through any more of these, but suffice to say that subsequent testing showed that arrays with max sizes of 5 through 8 could hold 8 objects, while 9 through 16 could accommodate up to 16. So what does this all mean? Well, it's hard to say exactly. I took a brief look at the C++ source code on GitHub, and from what I could tell, initializing an array by populating the max size argument should, in fact, yield an array fixed to that size. I'm not sure why the default is 0, but declaring an array with a size of 1 should give us a 1-index array. Likewise, initializing an array with a max size of 6 should give us an array capable of holding up to 6 objects. Something in SuperCollider's source code is clearly conflicting with this, and the only pattern I can deduce is that arrays' fixed sizes increment by powers of 2 when certain max size thresholds are crossed. But really, none of this matters, because the point I briefly made in the earlier video, one that I should have emphasized more from the start, is that you should always be setting the new array to a variable, either back to the same variable as before or a new variable. Even when adding a new object to an array past its fixed size limit, a new array is being returned, it just won't be stored anywhere in memory unless set to a variable. By doing this every time you use .add, it doesn't matter what the seemingly arbitrarily determined fixed size is, because you will always end up with the array you want. After a year of teaching SuperCollider to undergraduate and graduate students, I chose, much like I'm doing in this very tutorial series, to encourage them to adopt the GitLib way of doing things when composing their pieces or when live coding. That is, I emphasized the use of proxies. I still taught them the nuts and bolts of how Ndefs, buses, and signal routing works in the beginning, but after the first semester midterm, I shifted gears to GitLib, as I felt it helped reduce the anxiety of micromanaging every bit of how things under the hood worked and allowed them to focus more on music making. And for the most part, my hunch proved to be correct. However, I made one pedagogical error, and that was proxy space. Now, don't misunderstand me. There is nothing inherently wrong with proxy space, and I still maintain its versatility when live coding. However, how it makes use of environmental variables results in a boatload of confusion that was never truly resolved even by the end of the year. It was frustrating for my students to think of environmental variables as akin to global variables in other languages for the first half of the semester, only to have the rug pulled out from under them and being told they now behave differently, and they need to use interpreter variables or set up an event or similar namespace to store data that they want to be globally accessible. On many occasions, I get panicked emails from students because code that should be working returns a mysterious error, only for me to discover that they'd once again be using an environmental variable to store some value instead of thinking of it as a variable reserved for assigning node proxies to. It doesn't help my students when the vast majority of the documentation for, and online examples of, unfamiliar UGens make use of environmental variables in the normal way, so they're simply mimicking what they see others do. I began to repeat my mistake with this year's class until a particularly bright student just wasn't latching onto the concept like I thought they would. After giving it a lot of thought, I taught them how to use Ndef notation the following week, and with that, it clicked nicely for everyone. They could still approach environmental variables the way they have been doing since week 1, they very much appreciate the flexibility GitLib gives them in their compositional process, and are back on pace with regard to where they should be in the class. As such, I've decided to adopt the same tactic in these tutorials and will be transitioning from proxy space to Ndef notation. If ever I were to start a live coding series, I'd likely switch back, as I feel proxy space truly shines there as efficiency and clarity of code is paramount. But for compositions where one isn't in a rush typing code and others won't necessarily be peeking under the hood, Ndef is more than sufficient. To recap, setting something to an Ndef follows this syntax. Note the use of a symbolic name in lieu of an environmental variable, as well as the enclosing of the function or other object being set within the Ndef's parentheses instead of after an equal sign. On the other hand, instance methods are still set using an equal sign or the underscore parentheses setter notation. And we can still patch Ndefs into other Ndefs using the less than, and less than greater than operators. Furthermore, by using Ndefs, we no longer have to worry about pushing a proxy space and setting it to some variable as we boot the server. We can simply boot the server normally. Now that I've revisited arrays and Ndefs and touched upon these important points, it's time to move back into our exploration of sound design and create some useful one-shot gestures for our project, which we will begin in earnest next week. In the meantime, please don't forget to hit that like button and subscribe to this channel to show your support for more interactive digital music and art content from us at Null-state. Also, make sure to check out our Facebook page and webpage to stay up to date with all of our upcoming events. Links are in the description below. Happy coding!